Hi, today we are diving deep into the world of Elasticsearch and how it's architected for powerful search capabilities. So, whether you are building an e commerce platform, or analyzing logs, or creating a complex application, search functionality is the key. Elasticsearch is designed to tackle the complexities of full text search and provide fast, scalable solutions. Let's first talk about full text search and why it's challenging. So, imagine you are running an online clothing store and users want to search for items based on categories like, let's say, t-shirts, jeans, or even some specific colors like red or blue or pink or anything. A customer might even search for something like, let's say, a red cotton t-shirt. So your system needs to quickly find all the relevant products. Not only that, you would want to rank these results by price, availability, or popularity as well. So some customers might make typos in the spelling of, let's say, cotton, but still want to show them the correct items. So handling all this complexity and delivering fast, accurate search results is what makes full text search a difficult problem. But that's where Elasticsearch comes into the picture. So, what exactly is Elasticsearch? It's a distributed search and analytics engine designed for scalability and speed. So, Elasticsearch is built to handle large volumes of data and provide quick search results, making it perfect for applications that require real time search capabilities. But before we dive deep into Elasticsearch, let's get familiar with some key terminology of it. So first, let's start with nodes. So nodes are nothing but individual Elasticsearch processes running typically one per machine. Now multiple nodes form a cluster which acts as a single entity, allowing for distributed data management. Next, we have documents. These are simple JSON objects stored in Elasticsearch, similar to rows in a relational database. So, documents are grouped into indexes, which are similar to tables in relational database. As we can have a table of products or another table for user, we can similarly have indexes for that as well. Next comes shards. So shards are partitions. So each index can be divided into multiple shards, allowing Elasticsearch to distribute the data across different nodes. This distribution enhances performance by enabling parallel searches across shards. Now, to ensure data availability and reliability, Elasticsearch introduces primary and replica shards. So, a primary shard holds the original data while the replica shard duplicates this data for redundancy. So, imagine if a node fails, the data isn't lost as each shard's primary and replica are stored in different nodes, which is further accessible via replica shards. And of course, the number of replicas can be configured. Now, this configuration allows Elasticsearch to survive the loss of nodes without data loss. So, that's great, right? Okay, so now let's discuss how queries work in Elasticsearch. So, when a user performs a search, the request goes to any node in the cluster, which becomes the coordinator node. And this node then further communicates with the relevant shards which exist in another nodes to retrieve data. So for search queries, it hits all distinct shards utilizing both primary and replica shards. So probably not all nodes would be hit because you can get data from the replica shards as well, existing in the same server of some another primary shard. However, for a get query by ID, the coordinator node knows exactly where to find the document, which node contains that particular shard which has the required document. This allows quicker responses. Now, Elasticsearch is widely used across various industries. For instance, e-commerce site used it to help users find products quickly, filtering results based on user preferences and previous searches as well. Log analysis platforms like ELK Stack. ELK is Elasticsearch, Logstash, and Kibana. Logstash is for ingestion of data, and Kibana is a user interface to see the to visualize the logs. This leverage, so this ALK stack which I was talking about is leveraging Elasticsearch to help companies monitor their systems and detect anomalies in real time, allowing for immediate action. Also, financial institutes use Elasticsearch for analyzing transactions and identifying fraud patterns among millions of records, making it a vital tool for risk management. Apart from all this, these are the companies which you can see on the screen as well that uses Elasticsearch. Now let's understand the techniques to improve search relevance in Elasticsearch with an example of an online bookstore. First, let's look at a simple search query in Elasticsearch. Suppose a user is searching for books about Java programming. The basic Elasticsearch query would look like this. This query will search for keyword Java in the title and description fields of the books in our database. However, just because the word Java appears doesn't necessarily mean the result is the most relevant, as in that case we can get results for JavaScript as well, because JavaScript also contains a word Java in it. But that's not relevant. We can't consider it relevant. So we need to do something better. So how can we make sure that the best results appear at the top? One way to improve search relevance is by boosting certain fields that we know are more important. For example, a book's title might be a better indicator of what the book is about than its description. We can achieve this by assigning more weight to the title field in our query. Notice in the query that the title to the power 4 here boosts the title field by a factor of 4. It means that books with Java in the title will rank higher than those that only mention in the description. So by tweaking this boost, we can ensure more relevant boosts appear at the top of our search results. Now let's take this a step further. What if we want to boost search results based on user preferences? For example, books written in the user's preferred language or country might be more relevant to them. Also, those books which are recently published need consideration for the list of books which user get. So we need this query which combines field boosting with custom conditions. Now in this query we boost both books with Java in the title and books published in the United States. This allows us to balance relevance based on multiple factors as well. Let's break this down a bit more. Inside the functions property, we have two key objects. The first one is boost by country. The first function applies a filter based on country field. If the country field matches US, it multiplies the score by 2, giving this books a higher ranking. This means book from the US will appear higher in the results without completely ignoring books from other countries. Second comes boost by recency. We want to boost recently published books as well after we get the list of books of US. So what we can do is we can use field value factor which multiplies the score based on the publication date. So this ensures newer book gets a higher score, but we don't just sort by date. So we are balancing relevance and recency. After this, there's one more issue, like as we discussed earlier, there can be a typo as well, a spelling mistake as well. So what we can do to account those? We can use the fuzziness option in Elasticsearch to handle slight variations in search terms. This query allows for small mistakes like searching JVAA instead of Java. The actual spelling of Java is JAVA, but if a user search JVAA, then the fuzziness field set to 1 here means that it will account for one character. The difference of one character, so users will still find relevant results even with minor typos. So yeah, those were the techniques, and that's it for today. Thank you.